Hello, Algebra 2. So today we are doing lesson 6.6 and it is entitled Rational Exponents. You know exponents are, you know what exponents are, they're powers. Rational, as we've mentioned before in this class, you can think of as being fractional. The root word of rational being ratio, which is basically a fraction, numerator, denominator. So we're going to be looking at what happens when you have something raised to a power and that power is a fraction. So it comes down to this. The numerator of a fractional power is a regular exponent, whereas the denominator is a type of root or radical, and the denominator is the index. And so given anything to a fractional power, you can rewrite it as a root. So a to the 1/2 power is the same thing as a to the first power, right? That's this number. And then we do the square root of that. Now with square roots, you don't normally put a 2 here. And a first power, you don't normally put a 1 there. So a to the 1/2 is just the square root of a. Same thing as a to the 1/3. The a itself, you could put a 1 on to represent that, but you don't have to. However, with a cube root, you do have to put the 3 there as an index. So a to the 1/3 power is the cube root of a. I'm just using the a in every example to try and keep it simple. A to the 2/3 power then is the cube root of a squared. A to the 5/4 power is the fourth root of a to the 5th power. Now it just so happens that on a couple of these, like these over here, you could rewrite them like this instead, where the power is outside of the bar instead of inside of the bar, and it is considered to be the same thing. So those are two different ways to write the same thing. That's nothing to really worry too much about. You can do it one way or the other and it doesn't matter. What matters is that you know the top number is a power and the bottom number is the type of root. And that's the main point of what we're doing today. The rest of that is, it's what can you do with these things. So one thing you can do is rewrite the forms like I've done here. So you're given one of these, and can you rewrite it like this? Or on the other hand, if I give it to you like this, can you rewrite it like that? So going either way with these, learning how to rewrite them. That's pretty simple. Hopefully you'll see when we get to the examples. Simplify single rational exponents. Sometimes that can mean grabbing a calculator and having the calculator do some work. Other times it could be reducing fractions or combining things, that sort of thing. Simplify rational exponent expressions goes back to rules of exponents. For example, when you have two bases, the same base to different powers, and they're multiplied together, you can simplify this by adding the powers. When it's whole numbers, that's no big deal. This is something that should be fairly second nature to you. X squared times x to the 5th, well, that's just x to the 7th, 2 plus 5. When you have a power raised to a power, you multiply them. So b to the 3rd to the 4th, that's b to the 12th, 3 times 4. And for dividing, you subtract them. X to the 9th divided by x to the 5th, that's x to the 4th. You subtract 9 minus 5. When they're whole numbers, no problem. But what if it's a fraction? What if it's, instead of x to the 2nd times x to the 5th, x to the 2/3 times x to the 4/5? Well, it's the same rule. The rule is you keep the base and add the powers, but how do you add 2/3 plus 4/5? Well, 3rd, 4th, 5th, 6th grade, you learned how to do that, and then you haven't had to do fractions ever since, so you forget about that. But it's the same thing, we'll just have to deal with it. Same thing here, if instead of a 3 and a 4, what if it's 1/2 and 5/7? Well, you still have to multiply them, but now you're dealing with fractions. Same thing here, you still subtract them, but you'll be subtracting fractions. One note toward the end of this is we've already talked about how you cannot have a root in the bottom of a fraction. Like if you had 2 over the square root of 5, that's not allowed. And we went through this process called rationalizing. So you multiply by the square root of 5 over the square root of 5. You get 2 radical 5 over the square root of 25. And then that simplifies to 2 square root of 5 over 5. So you can't have a fraction like this with a root in the bottom. You have to do that. So this is something we've already covered a few times now. Well, since a fractional exponent is a type of root, right? Each one of these is a root. As it turns out, if you have like 2 over 5 to the 1/3 power, that's the same as having a radical in the bottom, which is not allowed. And so you kind of have to do a process similar to this. It works out to be a little different. So that's another thing we're going to talk about. All right. This assignment, when you look at it, looks pretty lengthy. And you see these last two problems, man, I just took a picture out of a different book. It doesn't even line up. This ends in 30. And shoot, I even have an even here and an odd there. So it's going to be a little messy at the end when I get here. But the point is, there's a lot of problems here, a lot more than normal, right? But the first, I don't know, 10 are pretty short and sweet and simple. So once you get through those, maybe the first 12, then it becomes a little more like work. But these are so quick and simple, it's not going to like bog you down in a lengthy homework process. So here, what are the directions? Write each expression in radical form. This is in fractional or rational exponent form. Radical form means to do what I did up here to these problems. So, I'm scrolling all over the place. I got to slow down. A 3/2 power basically means I'm going to be taking a square root of something to the 3rd power. This is that something. And I'm done. Or it could be written this way. Those would both be equivalent. You can go ahead and apply this power to both of those factors within the radicand, if you want to know the technical terminology. But either one of those would be considered a correct answer. I don't think the answer key has them both. I would seriously doubt it. Yeah, so they just do it that way. In fact, that's like my first answer right here, except they went the extra step of putting parentheses here, which I guess is a little neater. So how would I do this one? It's going to be the 4th root of something to the 1st power, right? 4th root, 1st power, and then n squared is that something. Now, 1st power is kind of special. When you have a 1st power, you don't actually have to write it down. So even though this is technically correct and it's in the same format as that answer, I bet when I scroll down to the answer key, it's just going to be that. Let me see. And there it is. Yeah, they did not bother putting a 1 out there because 1 is just a special number you don't have to worry so much about. Okay, number 6 is the same thing, only backwards. So what type of root is this? That is there is no index, which means it's a square root and a 5th power. So that means we're going to have something raised to the 5/2 power. The something is 7r. So that should be the answer. Conceivably, you could write the answer as 7 to the 5/2, r to the 5/2, but I doubt the answer key went that extra step. Let's check, and yep, there it is. That's all there is to that. Next one, again, the index of the root is the denominator of the power. The actual power is the numerator, and then this is the base. And here, since there's only one base, you really don't even need those parentheses. Like up here we had 2 bases, so you kind of include them in parentheses. So this should be just n to the 2/5 power. Let's check number 8. N to the 2/5 power, and there it is. See, these go kind of fast. Not a lot of working out and solving and simplifying and calculating, nothing like that. Okay, 343 to the 4/3 power. Well, I'm going to do what I did up here, even though I don't technically have to. I just want to, okay? So this is a 3rd root of 343 raised to the 4th power. So if you were trying to think this through, like, wow, what is 343 raised to the 4/3 power? Is this some sort of thing I can calculate? Well, a 3rd root, remember, is something times itself equals that number. And then to the 4th power means I got to take that something, and raise it to the 4th power once I know what it is. Oops, I have an alarm going off. Sorry about that. So, what do I do here? Well, I happen to know that, just because I do math for a living, for crying out loud, that 7 times 7 times 7 is 343. So the cube root of 343 is 7. Now I need to raise that to the 4th power. So I need to do 7 times 7 times 7 times 7. Well, as I just said, 3 of these is 343, so I just need to multiply that by 7, and that'll be my answer. Can I do 343 times 7? Sorry, yeah, 21, carry the 2, 28, 29, 30, carry the 3, 21, 22. So the answer here should be 2,401. Great. Do I expect you to do this? No, that's not the purpose of this assignment, to get you to do all that. I just wanted to go through one time and sort of conceptually explain what's going on in this problem. You root this, and then you take that answer and raise it to the 4th power. That's what's happening. More likely than not, you're going to be using a calculator. Now, I did do this. Oops, make that look like a regular 3. Either one of these you can type into Desmos, and many calculators have their own way of doing things, but you should be able to type this in to any calculator. Let me get rid of all this trigonometry I was doing. So first let's type this into the calculator. 343, then I hit the power button. Now since this is a fraction, I'm going to hit the divide button and put 4 over 3, and there's my answer. Or if I do the function button, miscellaneous, there's an nth root, and I want to do a cube root of 343, right? But then that I want to raise to the 4th power, and I get the same answer. So you can do either one of these formats in Desmos and get the right answer. That being said, what's number 12? 49 to the half power. Well, if you're using a calculator, 49 raised to the 1/2 power, 7 is the answer. Ironically, it probably would have been easier if you would have just changed this to, since a half power is the same thing as a square root. What's the square root of 49? 7. You know, you just know that because you know your times tables. Okay, and so that's about it, though. That's all you're going to be able to do on the calculator. I probably didn't want to erase all that, just some of the highlighting. So there's that answer, there's that answer. Ugh, I'd like to circle my answers. Let's see, that one wasn't really the final answer. Answer. Nope, that was not the answer that they used in the answer key. There. Okay. So 1, 3, 5, and 7 is just rewriting from one format into the other format. 9 and 11 is, you practicing doing these things on Desmos. And you can either do it as a power or you can do it as a root. That's up to you. But then we get into variables. 14 I'm not really going to be able to do on a calculator. What I am going to be able to do is this rule right here. When you have a power raised to a power, you multiply them together. So this is r to the 6 times 1/2 power. Well, what's 6 times a half? I guess if you wanted to use a calculator on this, you could. 6 times 1/2 is 3. I would really hope that you know that half of 6 is 3. So the answer is r to the 3rd power. Number 14, let me just double check. R to the 3rd power. Number 16 is going to be a little more complicated. So here's what we have to do. We have to apply this power to the 64 to the 3/2. There is no power here to multiply it by. But here we do have a power, so that's p to the 6 times 3/2. So I need to do 64 to the 3/2. I'll use the calculator for that. 64 raised to the 3 over, 2. That's 512. And then p to the 6 times 3/2. 6 times 3/2 is 9. Oop. 9. So this simplifies to 512 p to the 9th. Let me check and make sure I didn't mess anything up. 512 p to the 9th. So the ones that you're going to do over here, right next to those, very, very similar. You can just kind of use mine as models to help you do yours. Number 18. Oh, 18 is very similar to 16. So I need to apply this power to 10,000 and to that. So I get 10,000 to the 3/4 power, m to the 4 times 3/4 power. So let's see. 10,000 raised to the fraction 3/4 power is 1,000. M to the 4 times 3/4, 4 times 3/4 is third power. 1,000 m to the third power. So even these that I have to work out, because I'm using the calculator, and I wouldn't have to, I mean, I can do some of this math in my head, but you know, you're going to do what's easy probably. So grab the calculator. Even though it's a lengthy assignment, so far it's good, you know, cooking right along, not doing too bad. All right, what's next? Well, this is a multiplication problem, and you're going to have to handle this in parts. 4 times 2, those are just regular numbers. Don't worry about powers or anything. 4 times 2 is 8, no big deal. Then we have x times x squared. Well, I don't like the way I circled those. Let me, I'll just highlight them in a different color, sort of color code them. Yellow goes with yellow. X times x squared. Remember, x has a first power. If there's no power on a variable, it's a 1. So you add those. That's going to be x to the third power. This is stuff we did in the first quarter of the year, I think. And then let me change colors again, maybe green. The y goes with the y. Y to the 2 plus 1/3. So I need to add 2 plus 1/3. Well, 2 plus 1/3, quite frankly, is 2 1/3. But you don't usually use a mixed number as a power. That's not something that's done in algebra. So 2 plus 1/3, I know that's going to be, what, 6, 7/3, because I can do fractions in my head. If you can't do fractions in your head, 2 plus 1/3, and then hit the button right there, gives you 7/3, and there you go. Again, that's this button. Can you see where it's going from white to blue? That just converts your answer to a fraction. Let me check number 20. Make sure I didn't do anything wrong. There you go. So if you're really well functioning with fractions, you learned them well when you're a kid, and you can do stuff off your head, this will go really fast. If not, do what I'm doing. Split your screen, keep Desmos handy, and do your math that way. Number 22 is another multiply problem. 2 times the invisible 1 there is just 2. If I want to put my x's together, x to the 2/3, x to the 1/3, that's going to be x to the what? What's 2/3 plus 1/3? Hopefully you know that it equals 1 whole, right? Equals 1, so that's x to the first power. And then I need to get my y's together. Y to the 3/4, y to the 3/2. I need to add 3/4 plus 3/2. 3/4 plus 3/2. 2.25, let me hit that button. 9/4. So there's our answer. Actually, it'll probably just be 2x y to the 9/4, because a 1 power is not something you typically write down. And there it is. So your two problems are going to be like my problems. Actually, 17 is like 18, 19 is like 20, 21 is like 22. Kind of keeping it consistent for you like this. So anytime you do a homework problem, you can look right next to it and see kind of a similar example. This is, again, where we have to apply this power into the parentheses. So here we need to do a to the 5/4 times 1/3. Let me do that. 5/4 times 1/3. And then hit the fraction button. 5/12. And then b to the 3/2 times 1/3. Clear some of this off. 3/2 times 1/3. 0.5. Well, hopefully you know 0.5 is 1/2. So a to the 5/12, b to the 1/2. Let's see if that's right. There it is. And again, if you need a calculator, don't use one. All right. New set, simplify. Your answer should contain only positive exponents with no fractional exponents in the denominator. So again, when you have like bases, you are supposed to subtract the powers. Now this 3 doesn't have anything to simplify with, so whatever happens, I'm still going to have a 3 in the bottom of that fraction. But I need to subtract these powers. 4 minus 1/4. What is 4 minus 1/4? Should be 3 3/4. 3.75, which is 15/4. So that's x to the 15/4 over 3. That should be my answer. So the bigger number was on top, so when you subtract them, the x goes on top. It says no fractional exponents in the denominator. Well, we're good. We have a fractional exponent in the numerator, so that should be totally okay. Let's check and see. And there it is, x to the 15/4 over 3. So that wasn't so bad. Just subtract the powers. All right, let's look at this one. Very similarly, the 4 has nothing to divide or simplify with, so my answer is definitely going to have a 4 in the bottom. I need to subtract these powers. 1/2 minus 3/4. Oh, wait. Hold on. Clear that. That's wrong. I typed it in wrong. 1/2 minus 3/4. Negative 2.25. Negative 1/4. So what does that mean? Well, that means that I'm going to have in the bottom, the negative means it goes in the bottom as 1/4. So when you put it down in the bottom, it doesn't stay negative. I get that. It'd be like if I had n to the 5th over n to the 8th. 5 minus 8 is negative 3, right? 5 minus 8 is negative 3, taking a bigger number away from a smaller number. But if you write it like this, there's 8 down here, 5 up here. When you subtract them, there's 3 left down in the bottom. So instead of doing the negative power, you just write it down in the bottom of the fraction. So, okay, the rule is you subtract the powers. I subtracted the powers. I'm done, right? No fractional exponents in the denominator. So we need to now rationalize this. Let me get rid of that. That was just a miscellaneous example. How do you deal with this? Well, remember when we did it with roots, if you had something like, let me keep it simple, 1 over the square root of 2, we just multiplied by square root of 2 over square root of 2. That gave us square root of 2 on top, square root of 4 on the bottom, and the square root of 4 is 2. It's a perfect square. And now there's no root in the bottom. So this process of rationalizing, it's going to be kind of like that with a fractional power. We don't have to worry about the 4. The 4 is not a problem. It's going to stay there. We do have to multiply. Ugh. And it's got to be the same thing on top and bottom. It's going to obviously involve an n because the n is the thing with the power. But we're not going to multiply by 1/4. If I did, the rule is add the powers. 1/4 plus 1/4. Well, what's 1/4 plus 1/4? Hopefully you don't need a calculator. A quarter plus a quarter is a half, right? Just like with money. So that would just give me n to the 1/2. Well, that's still a fraction in the bottom. That doesn't do the trick. Instead of 1/4, we actually need to use 3/4. Why? Well, what we want in the bottom is no fractional power. That means we want a whole power, one whole. So the question is, what can you add with 1/4 to get one whole? Well, one whole is 4/4, right? So you need to add, a 1 with a 3 to get 4. So whatever the fraction is in the bottom, you need to add whatever it takes to make it equal one whole. And of course, what happens on the bottom also happens on the top. So to rationalize this one, we need to multiply by n to the 3/4 over n to the 3/4. Top times top, 1 times n to the 3/4 is n to the 3/4. I'm going to sneeze. Hold on. Oh, sorry about that. So on the top, 1 times n to the 3/4 is n to the 3/4. On the bottom, 4n to the 1/4 times n to the 3/4 is 4n to the, again, well, here, let me do it on the calculator just to prove it. 1/4 plus 3/4 is one whole. And then finally, you don't usually write a 1 in a final answer when it's a power. So n to the 3/4 over 4n. This should be the answer to number 28. Let me go down and check. And there it is. All right, this is going to happen again. So this is so complicated, I want to make sure we had a couple of these problems. First of all, when you divide like bases, you subtract the powers. The 2 has nothing to combine with, so it's going to stay up on top. For the b's, I need to do 3 halves, not 32, come on, 3 halves minus 2. That's negative 1/2. So remember, if there's a negative power, it goes to the bottom and then it stays and then it turns positive. So I get 2 over b to the 1/2. But you're not allowed to have fractional powers on the denominator, so you need to rationalize. So you need to ask yourself, what can you add with 1/2 to get 1 whole? Well, if in doubt, just subtract it from 1. And the answer, of course, is 1/2. Oops. So we need to multiply the top and bottom by b to the 1/2. Top times top is just 2b to the 1/2. Bottom times bottom is b to the 1, which is just b to the 1/2 over b. 2b to the 1/2 over b. Where am I? Good grief. There I am right there. Brilliant. All right, last problem is from a different paper. The directions are just simplify. This is not a division problem, so it's not really it doesn't follow the same set of steps and everything. This is just a simplify problem. So how do we do this? Well, there's a few ways to simplify this, but one way to look at it, by the way, I'm doing 37, which I know is odd. Usually I do the evens. Just think you want to do this column here. So you are going to do number 36, even though it's an even problem, right? Okay, so anyway, you can look at this as 81g to the 3rd to the 1/6 power, right? This is all sort of equivalent to being raised to the 1st power. 6 is the denominator. Then I can apply this 1/6 to both bases. 81 to the 1/6 g to the, well, I got 3 times 1/6. I know 3 times 1/6 is 1/2, but I'm going to pretend like I don't know. 3 times 1/6 is 1/2. And then can I simplify this? Let's check. 81, that's not an 81. 81 raised to the 1/6. Ooh, not so much. But what I can do is I can make a tree out of 81. 81 is what? 9 times 9, 3 times 3, 3 times 3. So that's 4 of them. So, okay, this is 3 to the 4th power to the 1/6, g to the 1/2. Well, again, when you have a power to a power, you multiply them. What is 4 times 1/6? 2/3. So that's 3 to the 2/3 g to the 1/2. Oops. Well, we're just about done, so it's okay that my battery's dying. And there is that answer. So that's kind of how you're going to do this one. You're going to make this into a power, like that. You're going to apply it to both bases. This base, you're going to do a factor tree, and then simplify it from there. Okay, do your best on this. Contact me if you have any questions. I will try to help you out through a Google Meet or whatever. And if it goes well, great. Just don't forget to show your work and check your answers before you turn it in. I will talk to you later. Have a great rest of the day.